All right, guys, so we got a couple more of these systems to get through. I figure we have that one, and this one. I figure we'll do 2 out of 3. If you want to do the third one on your own, okay, I'll leave that up to you. So why don't we'll try these guys right here. Okay, so you have a quadratic that opens up, okay, and you have a horizontal line, okay, y = 8. Okay, so obviously they're both set up, so if both of these guys on the right are equal to y, then they have to equal each other. So they kind of set us up, okay, to make it a little bit easier on us. Okay, so set these equal to each other, and then put it in standard form, so I'd have to subtract 8 from both sides. So I get 2x squared plus 7x minus 5 = 0. I am wondering if this guy will factor, and no, I don't think it does, but I'm going to check b squared minus 4ac just to be sure. So let's see, 7 squared is 49 minus 4 times 2, okay, times -5. Okay, so that is 49 plus, that'd be 40. So I'm getting 89, and 89 is definitely not a perfect square, so it does not factor. Okay, all right, so let's see. We're going to go x equals the opposite of b, so the opposite of 7, plus or minus the square root of, well, b squared minus 4ac already figured out is 89, all over 2 times a, so 2 times 2 is 4. Okay, so again, just like the last ones, could we, you know, say, okay, this is our exact x coordinate? Could we go back in and, oh, wait a minute. I think we can. Because don't we know y is 8 on the nose? Okay, so, geez, I don't think I have to worry about that, because no, we know that y is 8. So we know if this guy intersects with this horizontal line, okay, that every point on the horizontal line has a y coordinate that's 8. So I know that both of these have to have a y coordinate that's 8, and I don't even have to go ahead and do any evaluation. Okay, so let's see. So our solutions, boy, that I just noticed that. Well, that makes life even better. So we get -7 plus radical 89 over 4 and 8. And our other guy would be -7 minus radical 89 and 4 over 8. Okay, now, I would, at the very least, I would check. Okay, now see, let's see, how are we going to check this? Well, I'd say, okay, why don't we punch this into our calculator and round things off, and then substitute it in here in this first one and see if we get something real close to 8. Okay, so I'm going to check it. So let's see what we got going on. All right, so I'd have -7 plus second 89, hit enter, and then divide by 4. Okay, so I get roughly about positive 0.61. Okay, and then if I go -7 minus square root 89, and then divide by 4, I get roughly about -4.11. Okay, so if we're in good shape, both of these, when I substitute them in here, should give me something close to 8. Okay, so let's see what happens. Y equals, that would be 2 times 0.61 squared plus 7 times 0.61 plus 3. And let's see if we get something close to 8. Okay, so we have 2 times 0.61 squared plus 7 times 0.61 plus 3. And we're getting 8.01. Okay, so obviously pretty close to 8. Let's check the other one. Y equals 2 times -4.11 squared plus 7 times -4.11 plus 3. And let's see what happens here. Okay, 2 times -4.11 squared plus 7 times negative 4.11 plus 3. And notice I'm getting 8.01 again when it's rounded off. Okay, so I should feel pretty good. Boy, I just, just noticed that right when we were finishing up that first part of it. Boy, that makes life easy. Okay. All right, let's try one more of those guys. Okay. All right, so if these are both equal to y, they have to be equal to each other. So I get negative 3x squared minus 2x plus 1 equals negative 9. And then if I add 9 to both sides, I get negative 3x squared minus 2x plus 10 equals 0. I could divide through by negative 1. I hate having a negative leading coefficient. So 3x squared plus 2x minus 10 equals 0. Now, will that guy factor? I don't think so, but I'm going to check b squared minus 4ac and see what happens. So b squared is 4 minus 4 times 3 times negative 10. Okay, so this is 4 plus 120, and I get 124, and that is definitely not a perfect square. So it doesn't factor. Okay, so let's see, x equals the opposite of b, negative 2, plus or minus the square root of, well, b squared minus 4ac is 124. Okay, all over 2 times a, so that'd be 6. Okay, now 124, okay, that is definitely not in simplest radical form. So 124, let's see, divided by 4 at the very least. It's 4 times 31. 31's prime, so that's all I can do. So I get negative 2 plus or minus 2 times the square root of 31 all over 6, and then I can reduce that. Divide everything by 2, so I get negative 1 plus or minus radical 31 all over 3. Okay, so my solutions, and don't forget, okay, the 2 points, okay, where these guys intersect, both points have a y coordinate of negative 9, because every point on the line y equals negative 9 has a y coordinates negative 9. So we can come up with exact y coordinates. So negative 1 plus radical 31 over 3 and negative 9. Okay, and then negative 1 minus radical 31 over 3 and negative 9. Okay, and I will certainly check these. Okay, so let's see. If I punch this into my calculator and get an approximation for x, let's see, negative 1 plus square root of 31 divided by 3. I'm getting about 1.52. And then if I go minus, so I got negative 1 minus square root of 31 divided by 3. I'm getting roughly about a negative 2.19. Okay, and so if I substitute these into the first equation, let's see if I get something real close to negative 9. Okay, so y equals negative 3 times 1.52 squared minus 2 times 1.52 plus 1. And if it comes out real close to negative 9, I should feel good about that one. So let's see, negative 3 times 1.52 squared minus 2 times 1.52 plus 1. I'm getting negative 8.97, so obviously real close to negative 9, so I should feel good about that guy. Okay, let's do it for negative 2.19. So negative 3 times negative 2.19 squared minus 2 times negative 2.19 plus 1. And let's see what happens. Negative 3 times negative 2.19 squared minus 2 times negative 2.19 plus 1. I'm getting negative 9.01 when it's rounded off. Okay, so obviously we should feel pretty good about the numbers we came up with. Okay, so we're in good shape there. Okay, like I said, this last one, I'll leave that for you. Okay, obviously very similar to the two we did, and see you guys in class.